Everyone, it's Mrs. Sommer here to talk about lesson 103, the Bohr model. In this lesson, students will be able to define the energy levels of an atom, identify the valence electrons using the Bohr model. So if you remember from last lesson, lesson 102, the atomic symbol for this is Be, for beryllium. The atomic number is 4. The atomic mass is 9.01. When you're asked for the number of the atomic mass, you write everything that comes after that decimal, remember. The number of protons in this is 4. The number of neutrons, remember, was 9. This is where we round the atomic mass, minus 4, 5 neutrons. And the number of electrons in a neutral atom is the same as the number of protons. So the Bohr model is a representation of the atom. It's sometimes called the Bohr diagram, the BR model diagram, or the Bohr-Rutherford model. And how we do it, we draw it, is the center is the nucleus. The center circle is your nucleus. Then each additional circle is an energy level of the electron cloud. So if we look here, they drew their nucleus. And inside the nucleus, you need to write, so inside nucleus, write number of protons and number of neutrons. You don't have to draw the number of neutrons and number of protons, just write the number, just like right here. And then each additional one. So for helium, it only has 2 electrons. So it only has 1 electron ring. Lithium has 3 electrons. And it has 2 rings. And we'll get to that in a second. So electron cloud energy levels. So each energy level can only store a certain number of electrons. So level 1, or the first ring after the nucleus, can only hold 2 electrons. Level 2 can only hold 8 electrons. Level 3, 18, and level 4, 32. So if we are looking at this, so this Bohr model, the atomic symbol would be beryllium. The atomic number is 4. The atomic mass is 9.01 from previous. 4 protons, 5 neutrons, and 4 electrons. And so we drew our nucleus here, and you do 4p plus, 5 and not. And then since the first energy level after the nucleus can only hold these 2 electrons. Once you've done that, now we still have how many electrons? We started with 4, we used 2, so we have 2 electrons left. So now you try it. Draw the Bohr model for oxygen. So the Bohr model for oxygen's atomic symbol is O. Its atomic number is 8. Its atomic mass is 15.99. Number of protons is 8. Number of neutrons is 8. And the number of electrons is 8. So I'm going to start by drawing my nucleus. Then I'm going to write 8p plus, 8 and not. Then I'm going to draw my first energy level. And then I'm going to change the color. So then I put 2 electrons in my first energy level. Then because oxygen, let's say we have 8 total electrons. We put 2 in that first energy level. We have 6 electrons left. So now I have 1, 2, 3, 4, 5, 6. And there is a total of 8 because 6 plus 2 is 8. And that would be the Bohr model for oxygen. Now you try the Bohr model for aluminum. So aluminum's atomic symbol is Al. Its atomic number is 13. Its atomic mass is 26.982. It has 13 protons. It has 27 minus 13, 14 neutrons, and 13 electrons. And then I'm going to erase that so I can have room to draw. So I need to first draw my nucleus, And I'm going to write 13p plus, 14n naught. And then I'm going to draw my first energy level. My first energy level can only hold 2 electrons. So I had 13 minus 2, I still have 11 electrons. Then I'm going to draw my next energy level. My next energy level can hold 8. So I have 1, 2, 3, 4, 5, 6, 7, 8. Minus 8, and I have 3 left. So I need to add another ring because I can only put 2 electrons in the first energy shell, 8 electrons in the second energy shell, and this energy shell can actually hold up to 32, but I only need to place 3 for aluminum. So this is the Bohr model for aluminum.